Hey guys, sorry this is a little bit late. We're doing vocabulary data and variation in data. So, this is your 6.2 section. Sampling and data, definitions, sampling and variation, how it changes. The experimental design and ethics we'll do later. Number 1. Definitions of statistics, probability, and key terms. The science of statistics deals with the collection, analysis, interpretation, and presentation of data. Organizing and summarizing data is called descriptive statistics. That's what we're doing here in Module 6. 2 ways to summarize data are by graphing and by using numbers, finding an average. After you've studied probability, that's Unit 7 that we won't get to, and probability distributions, you will then use formal methods for drawing conclusions from good data. These formal methods are called inferential statistics, and that would have been Unit 8. It's basically just a couple of projects, but we're not going to get to that either. Probability is a mathematical tool to study randomness. It deals with the chance or the likelihood of an event occurring. There's a lot of probability that is into statistics, and they do it anywhere in sports, have a lot of it that comes through. It's used a lot in when they are doing medicines, when they are evaluating different outcomes for even engineering and things. They'll use probability. The mathematics is how you analyze with the probability. So definitely is something that comes up a lot. In statistics, we generally want to study a population. You can think of a population as a collection of persons, things, or objects under study. That's a large section. Okay? To study the population, you select a sample of the population. So if the population's here, then your sample is here. You're pulling something out. The idea of sampling is to select a portion or subset of the larger population and study it to gain information about the population. Data are the result of sampling from a population. So when I'm looking for how many people rode the bus to work in the morning, my population would be all workers, and then it would be a subset of riding the bus. And you want to make sure that you picked enough people that actually were the whole population. You've got people who drove, you got people who walk, you got people who carpooled, and you've got the bus riders, and it's the same sort of proportion. You want to make sure that you are staying, that you're reading the same things. You don't want to just go to a bus stop and then pick these people at the bus stop. How many of them ride the bus? Well, all of them ride the bus because they're all at the bus stop. That would not be a very good sample. You would have to do, and we'll get into sampling later, but that's what it is in terms of getting a sample. You want to make sure it represents the real population. From the sample data, we can calculate a statistic. A statistic is a number that represents a property of the sample. The statistic is an estimate of a population parameter. A parameter is a number that is a property of the population. Okay, the sample must contain the characteristics of the population in order to be a representative sample. Okay, that matches what you've got. A variable, notated by capital letters such as X and Y, is a characteristic of interest for each person or thing in a population. Variables may be numerical or categorical. Numerical variables take on values with equal units such as weight in pounds or time in hours. Categorical variables place the person or thing into a category. For example, a political affiliation, eye color, gender, ethnicity. Okay? So just categorical ways to classify somebody. Data are the actual values of the variable. They may be the numbers or they may be words. Datum is a single value. Okay. Here we go. Example number 1. Determine what the key terms refer to in the following study. We want to know the average or the mean amount of money first-year college students spend at ABC College on school supplies that do not include books. We randomly survey 100 first-year students at the college. 3 of those students spent $150, $200, and $225 respectively. So, what is the population? Well, the whole thing that we're talking about, the whole item, is all, see if I can find my thing, there we go. All first-year students at ABC College this term. All right, there's your population. That's the whole thing. Your sample, you've got to pick a random sample, and this could be, because it could be different ways to do this. One section of a beginning statistics course. Okay, might be a little bit weighted because it may not, everybody may not be taking a math course. But that's one way to get first-year students randomly. I guess another one could be that you'd grab 100 first-year students out of a dorm. Anywhere first-year students were gathered together, you could grab 100 of them to be random. But it's got to be random. A parameter. What we are setting up, the parameter of this is the average amount of money spent. There it is. Can't find the pen. The average amount spent, and that excludes books. Okay? Excluding books. Your statistics, your statistic is, okay, the statistic in this case is pretty much the same thing. But these are the, this is how we're classifying it. The parameter is what we're classifying it by. The statistic here is going to be the numbers that we come out with. The average amount spent. Okay? The variable. Let X equal 1 first-year college student. Or 1 changing. 1, 2, 3. Okay? But 1, that's a variable. Data is those dollar amounts up here, 150, 200, and 225. That's data. That's amounts actually spent. Okay? That's that 150, the 200, and the 225 up there. That's actual data collected. And different students spend different amounts. Okay? That's about 9 minutes, so let's cut this one off here and we'll start a new one in a second.